In this video, we're going to talk about properties of logarithms. Some of the first properties we're going to talk about are of common logarithms. So very basic things that are very easy to prove and patterns that you can find on your own pretty easily. The first one is log base b of 1 equals 0. You can prove that b to the 0 power is 1. And then these two, if you have the same base and this result number, whatever the power is going to be the result. So b to the first power is b. B to the x power is the same as b to the x. So these two things will cancel and give you whatever the power is left. In the same token, if you have a base to a power of a log with the same base, that's going to cancel out and give you whatever is left over as the result as your answer. And some other ones with just some numbers. Log of 1 is always 0 because that's a 10. 10 to the 0 is 1. And then log of 10 is 1 because 10 to the first is 10. Log of 10 to the x, because these two things are the same, just like over here. It's going to give you that exponent back. And same deal with this rule number 4 here. 10, because that is a 10 there. Those two things cancel and give you whatever the result is left. So there are 4 more properties that we can talk about because logarithms are another expression of the inverse of an exponential function. We can actually use the law of exponents to help us define more properties of logs. So those 4 that I want to explore with you guys is product, quotient, power, and equality. So if I'm given some log base b of m and n, depending on what I want to do with log base b of m and log base b of n, I can actually either pull those apart and expand them, or I can take that expansion and then condense it, so going forwards and backwards. Let me show you what I mean. So for the product, if I have these two things multiplied together, I can actually expand them and make them addition, much like the rule with an exponent. So with a quotient, I'm going to follow the same exponential rule. If I divide those two things within the same log with the same base, I can actually break them apart and subtract them. The power rule is if I have this result to a power, I can bring the power to the front. So it would become whatever the power is times that log base b of m. And then the final one here is of equality. So if I have log base b of m equals log base b of n, then because they have the same base and I'm applying the same logarithm with the same base to them, m is going to be equal to n. So let's take a look at an example where I have to expand a log. So if I have log of 3 times 2 to the third power, I'm going to use the product rule and break that up into log of 3 plus the log of 2 to the power of 3. So I'm almost done. Because this has an exponent here, I can actually move that to the front. So this becomes log of 3 plus 3 times the log of 2. And I can break this apart because it has the same base right here, which is 10. Looking at another example, I have the log of the quantity x times y times z all to the 1/3 power. So what I'm actually going to do first is I'm going to rewrite this as x times y times z to the 1/3 power. So I know that this 1/3 will eventually go on the outside, and in fact I can do that now if I choose to. So now I can break apart my multiplications here, and this will be log of x, log of y, plus log of z. Or another way to write this is log of x over 3 plus log of y over 3 plus log of z over 3. Either will work. So now let's work backwards. Let's look at this example where it asks me to condense log base 3 of u minus 5 times log base 3 of v. The first thing I notice is that I have the same base, which is 3, which allows me to combine these into one expression using log base 3 of something. Another thing I have to consider is this subtraction right here. and I know that that subtraction results from division. So I know that whatever log base 3 is being taken of, it will be a division. So I take a look at what's on the left side and the right side. On the left side I have a u, and then over here I have 5 times the log base 3 of v. And I know that the 5 results in front because it used to live as an exponent of v. So really, this is going to be log base 3 of u over v to the 5th. And if I'm unsure, I can check that going backwards because I know division will result in subtraction, and it'll be log base 3 of u all over 5 times log base 3 of v, which is that side over there. Let's take a look at a more challenging example. So the challenge here is not that it requires anything different, it's just that I have to remember all of the rules and apply them here and work in a kind of backwards order in order to condense it into one log expression. So what I'm going to do is I'm going to treat each of these separately, and what allows me to do that, as the others, is that I have the same base. So if I approach this first part, I'm going to have 2 times log of 2x all over y, because this subtraction results in a division. And then on the right hand side, I'm going to have log, subtract that, I'm going to have log 3 times 5 squared. So remember that 2 goes back up here, and that plus results in multiplication. So I'm going to work that out, and that's going to actually give me log of 75, because 5 squared is 25, times 3, that's 75. And over here on the left, this 2 goes back here, much like this rule. So that's going to give me log 2x over y squared, which I will make simpler. 2x squared is 4x squared all over y squared minus my log of 75. So now I'm to the point where I've got 2 log expressions and I have a subtraction, so I can write this as log of 4x squared over y squared all over 75. And from here I can just move my y squared down, knowing basic rules about rational functions. So my final expression is log of 4x squared over 75 y squared. So the last thing that we'll talk about is change of base, which is really helpful in the calculator, especially if you have an older version like a TI-84, TI-84 Plus. The log base as a function may not be readily available on your calculator. So this will work on any calculator, 84 or above, and it actually is really useful in just knowing how to change the base when it's not a base of 10. So the rule is I take the log of this resultant number and divide it by the log of the base, because they have the same base, which is unwritten as 10, and if I actually plug that into a calculating device, I get the same answer. So I can see that here where I plug in what's originally written, log base 5 of 89, and I get the same result as when I divide log of 89 base 10 by log of 5 base 10. And mission accomplished. This video is over. Good work.